very strong marketing argument for you. You all know that everybody is talking about blue light in terms of skin damage, in terms of hyperpigmentation, so spots, uneven complexion, melasma. And again, as we've discussed in the past, we are the only ones that have demonstrated biological activity against blue light damage. So we'll continue. Sorry, just there are messages coming in. Sorry about that. So in terms of background and introduction, as you know, Fernblock has been demonstrated to protect against skin damage caused by visible light being 400 to 700 nanometers, in vitro and in vivo. As you know, blue light is the most harmful high energy part of the visible light spectrum, and it's been shown to increase the production of reactive oxygen species, inflammatory mediators, DNA damage, as well as induce melanogenesis and MMP activity, resulting in premature photoaging and hyperpigmentation. Okay, so blue light, part of visible light, responsible for skin damage, particularly pigmentation and aging. In addition to natural sunlight, electronic devices are an important source of blue light radiation, and intense exposure to electronic devices during the day, as well as increasing nighttime exposure to artificial light, can be considered to be detrimental to the skin. So blue light comes not only from the sun, also from the digital devices, which we use all day long and which we use at night, and then from the artificial light. So our skin is exposed to a large quantity of blue light every day. As I said, previous results presented in a poster form demonstrated that Fernblock can help protect against skin damage caused by blue light from digital devices, increasing cell survival and reducing oxidative stress, mitochondrial morphology disruption, and pigmentation. This article presents this data and adds new important findings regarding Fernblock's ability to prevent photo-oxidation of melanin precursors and activation of Opsin 3, an important pathway involved in hyperpigmentation. So the two new elements that I discussed previously are the prevention of the photo-oxidation of melanin and the activation of Opsin 3, which is an important pathway involved in hyperpigmentation due to blue light. The study, human fibroblasts and melanocytes were irradiated with radiation wavelengths mimicking those emitted by screens of electronic devices before and after treatment with Fernblock. The irradiation dosage used for the majority of the trials, 38 joules per square centimeter, was the equivalent of 290 hours of exposition, or for example, 6 hours a day for 7 weeks. Okay, so we're talking about a period of exposure to blue light, which is really very realistic. Okay, 6 hours a day for 7 weeks. We know that more than 7 weeks and more than 6 hours a day is what we're being exposed to. What are the results? This you've seen before, that the artificial blue light significantly reduces cell viability, so cell survival, and alters the morphology. Here we see cell viability, control, irradiation. We have a decrease in cell survival, but with Fernblock, we are able to preserve the cells. Okay, so the quantification, but also very good images. You can see here, this is the these are the fibroblasts that have not been treated with Fernblock. The structure of the fibroblasts has been changed. These dots represent damaged or dead cell material. Okay, so here very clearly we've been able to prevent cell damage and death due to the blue light. Oxidative stress, we know that blue light creates oxidative stress. Here we see the increases in oxidative stress in fibroblasts. With Fernblock, we are able to almost completely eliminate it. Morphology, mitochondrial morphology. Again, this was also included in the poster. Here we see normal, healthy cell mitochondria. Exposure to the blue light, you see that the nucleus has become flattened, and there is less distinction and limitation between the nucleus and the surrounding cytoplasm. Okay, so obviously there has been damage to the nucleus, there has been damage to the mitochondrial cell. Here with Fernblock, we see that the structure is very similar to the control, the rounded nucleus, and the separation between the nucleus and the cytoplasm. Pigmentation. Okay, this is an interesting image which can be useful in marketing and communication. This is these are human melanocytes, control, irradiated with blue light. We see that there is a noticeable increase in the quantity of melanin. Treating the cells with Fernblock and then irradiating, we see we have been able to significantly reduce the amount of melanin that's been produced. This occurs both extracellular and intracellular. So here we have, again, the control, the irradiation, the increase in melanin, statistically significant, and then the reduction in the melanin that we're able to receive by using Fernblock. Again, statistically significant. Okay, so here, powerful data on the amount of pigmentation present in the skin. Why does this happen? Okay, two reasons. We said one was the photo-oxidation of melanin. You know that we all have melanin naturally present in our skin. Blue light, because of the oxidative stress, causes photo-oxidation of melanin, and through photo-oxidation of melanin, the melanin becomes darker. Okay, so here, this mechanism is increasing the darkness of the pigmentation. Here you see a very good example of what happened. This is normal melanin. Okay, and it's all irradiated with blue light in the melanocytes with Fernblock. We see that there has been no darkening of the melanin, whereas in the control with no Fernblock, there has been significant darkening of the melanin. Okay, so this is what happens in a laboratory. This is also what will happen in the skin. So we're increasing the quantity of melanin, its darkness is increasing, and then the Opsin 3 pathway. Okay, again, this is very scientific, but in the scientific literature, there are a lot of articles regarding the role of Opsin 3 in contributing to hyperpigmentation due to blue light, because of course, studies are showing that there is increased pigmentation, increased skin darkening because of blue light. Scientists are trying to understand why this is happening. One of the reasons this is happening is that a pathway called the Opsin 3 is being activated by the shorter wavelengths of the visible light spectrum. Okay, so remember, visible light goes from 400 to 700, the blue light from 400 to 500. So it's the blue light that's activating these proteins on the cell membrane. These activated proteins are then inducing an increase in melanogenesis enzymes such as tyrosinase and dopachrome, okay, which you know are involved in the process of melanogenesis in the increase in melanin. So what we see is that blue light increases the expression of Opsin 3. Here we go. This is our control, the measuring of Opsin 3. Irradiation with blue light, okay, a significant increase and activation of the Opsin 3 pathway. In the cells that have been treated with Fernblock, we get a significantly statistic reduction in the activation of Opsin 3. Okay, so here we've seen that we have less pigment produced. We see that the pigment is less dark, and one of the reasons why is that Fernblock is helping to reduce the activation of Opsin 3. As I said, this is an important topic at the moment with dermatologists because it's explaining why we're getting skin darkening from blue light. So the conclusion, obviously, Fernblock can help protect skin against skin damage caused by blue light from digital devices, increasing cell survival and reducing oxidative stress, mitochondrial morphology, and pigmentation. The reduction in pigmentation is achieved through a number of different complementary mechanisms. Okay, the most interesting is the reduction in the Opsin 3 activation, Opsin 3 being one of the main pathways involved in melanogenesis. I'm going to skip the second one for a moment because it's very technical and I don't think that we need it at the moment. We'll go into it perhaps in discussions in the future. But again, not to overload you or our doctors with too much information, quite technical. And then we have reduction of in the oxidation of the melanin precursors. This leads to a significant reduction in intra and extracellular pigmentation. Fernblock can thus provide important protection against skin aging and hyperpigmentation caused by blue light, including that emitted by digital devices. Okay, so what's the conclusion? Obviously, we know that increasing attention is being placed by both the scientific community and consumers on skin damage caused by blue light. These are scientific articles. Then in the web, in the media, lots of discussion about blue light. Products are beginning to introduce claims regarding protection against blue light, but again, as we've said in the past, mainly due to the presence of mineral filters, such as non-nano titanium dioxide, iron oxide in the form of pigments, and antioxidants with generic claims. Okay, so our competition is talking about blue light protection, but usually through a mechanical or antioxidant activity. Fernblock is the first active with demonstrated activity against blue light, cell survival, reducing oxidative stress, protecting cell morphology, and then what will be important for you in your markets, the decrease in the pigmentation by reducing the oxidation of melanin and a reduction of the Opsin 3 expression. So this is really cutting edge research because we have demonstrated two things. We have demonstrated that exposure to blue light causes skin damage. Okay, we saw earlier 6 hours a day for 7 weeks has given this kind of damage. It's not unrealistic to think that people are being exposed to that and much greater radiation. And then we've looked a bit farther into the mechanisms that are responsible for the damage and have demonstrated that Fernblock can be helpful. And what does this mean? That HelioCare 360, our photoimmunoprotection brand, provides the most complete photoprotection against the 4 radiations, UVB, UVA, visible light, including blue and infrared. The importance of photoprotection all day, every day. We've discussed this before. It's a perfect chance for us to take out the seasonal element in the sales of sunscreen, okay? That there's a big trend to buy sunscreen when we get to the summer periods when people are outdoors more, where the sun is more intense. But really, with the knowledge we're gaining about blue light, we need photoprotection all day, every day. And particularly important in the prevention and adjuvant treatment of hyperpigmentation because of the role of visible light, because of the role of blue light in hyperpigmentation, especially in the darker phototypes, 3, 4, 5, okay, which are the most susceptible to damage from the blue light. So, again, I apologize. It's a rather complicated technical study, but I think that if we look at the conclusions, we can deliver it very nicely to our doctors and pharmacists.